October 2nd, 2025. On the frozen sky of Mars, where the wind moves across red dunes like the ancient breath of the planet, a streak of light flashes by, so fast that time itself seems to hesitate. In that stillness, the lens of perseverance, the lonely eye of humanity on a distant world, captures something no one can quite explain. A thin beam, no wider than a thread, cuts through the star field, moving against the motion of the heavens. It travels at 60 kilometers per second, so fast that the familiar logic of orbit ceases to make sense. The object has a name, 3I Atlas, a wanderer from beyond the solar system, a visitor from interstellar space like the rare few before it, Oumuamua and 2I Borisov. But Atlas is different. In a composite of images stitched together by amateur astronomers, its light doesn't drift along with the rotation of the stars. It cuts across, forming an impossible angle. And then, in those same frames, someone notices something even stranger. Not just one glowing point, but several. Faint dots, moving in diverging directions, as if the sky itself were filled with a swarm of counterfeit stars. In the third frame, a flash of blue, not a cosmic ray, not image noise, but real luminescence, spreading for a few hundredths of a second before fading away. In astrophysics, that blue hue signals oxygen or diatomic carbon, two carbon atoms bound together, reacting under sunlight. Yet the spectrum of 3I Atlas, captured by the Very Large Telescope in Chile, shows almost no trace of dicarbon. The object shouldn't be glowing blue, and yet it is. In the days that follow, the astronomy community bursts into speculation. Some claim it's a fragment of icy debris reflecting sunlight. Others believe multiple objects are traveling in formation, like a caravan hidden in the dark. NASA and ESA, agencies that usually release raw data within hours, remain silent. No files, no statements, no explanations. The silence itself feels heavy, echoing through the void. On Mars, Perseverance keeps watching in stillness. Beneath a sky without air to carry sound, the images it sends back to Earth become the only witnesses to that moment. 3I Atlas, in its strange trajectory, slices across the heavens at unimaginable speed. A living memory of something older than the sun itself. Perhaps it's nothing more than a drifting shard of rock and ice. Or perhaps it's a remnant from a civilization long gone, extinguished in the dark between galaxies. Yet in that instant, when the blue light flared, in that fraction of a second between two frames, humanity felt something deeper than explanation. The quiet realization that the universe still keeps its secrets. Secrets that move silently, crossing the limits of science and intuition, gliding through the red night of Mars before vanishing behind the sun, where no one can see. From that moment on, the question was no longer, what is it? It became, what are we standing before? And in the silence of the space agencies, a primitive feeling stirred. The uneasy sense that out there in the dark, more than one light might be watching back. When the faint light of Mars glimmers against the cold silver antennas on Earth, an unusual silence sweeps through the scientific community. Normally, images from NASA and ESA's orbiters appear almost instantly after transmission, raw, unprocessed snapshots of the red planet's surface, its thin skies, and the distant motion of stars. But this time, the data stream stopped. No images, no announcements, no explanations. Only a quiet void where updates had arrived, without fail, for the past 2 decades. In science, silence is its own language. It speaks not with words, but with delays, with unexplained waiting, with the absence of data where data should exist. At NASA, observation batches are typically processed and released within 24 to 48 hours, unless there's a transmission glitch or something that doesn't quite fit protocol. So when both NASA and the European Space Agency suddenly stopped releasing data on 3I Atlas, people started to wonder. Why were the images withheld? Was it just a technical hiccup, or did something appear in those frames that made scientists pause, look closer, and choose silence over haste? Those familiar with the inner workings of planetary missions know that every image from orbit goes through layers of processing: optical calibration, radiation balancing, cosmic ray filtering, coordinate mapping. The entire cycle usually takes half a day, longer if the target is moving fast or the light is dim. But when more than 2 days passed with no results, amateur observers began murmuring about a blackout, a communications shadow around Mars. At the data center in Pasadena, image-bearing radio bands from the Mars Reconnaissance Orbiter were still coming in steadily, yet no one outside the core team had access. Project insiders were told only that the data was under analysis, a phrase science sometimes uses in place of "we're not sure what we're looking at." Over at ESA, both the ExoMars and Mars Express missions logged data during the same time frame. The official statement was brief. Observations proceeded as planned. Data will be released after standard verification. Behind those stiff words lay a long pause of caution. Both agencies had learned from premature announcements that later had to be retracted. They knew a single anomaly in a spectrum, a faint unidentified glow, could ignite global speculation. Still, not everyone bought that explanation. On astronomy forums, a new phrase began to circulate: coordinated delay. People recalled other silences in history, when Voyager captured strange formations near Triton, or when Oumuamua's heat signature data was quietly withheld for weeks pending review. In every case, anomaly was the official reason for keeping quiet. But silence can also mean fear, the kind that grips scientists when they face something beyond the edge of understanding. Not everything unusual is unnatural, yet not everything natural is easily explained. Somewhere between those two truths, caution turns into darkness. At Cambridge, a small group of independent astronomers compared Mars transmission logs with satellite relay schedules. They found something odd. During the window when 3I Atlas images should have been sent, there was an 11-minute communications gap, simultaneous across both NASA and ESA channels. No official comment was made. Some said it was mere coincidence between two separate relay systems. Others believed part of the signal may have been intercepted, either held for review or rerouted to a private server beyond public access. But the real story isn't the conspiracy, it's how silence spreads. In science, information moves at the speed of light, but silence moves like shadow, slow, deep, and almost impossible to chase away once it appears. With no new images, the community turned back to old frames, those from Perseverance, where that faint blue streak still lingers, trailed by tiny points moving in parallel, still unexplained. In that void, every theory becomes possible. Natural debris torn from a comet, reflective ice fragments, or perhaps even artificial structures drifting in orbit. No one knows, because there is nothing left to confirm or deny. When humanity runs out of answers, it looks to silence for meaning. And in the shared quiet of the world's two greatest space agencies, people began to sense something else. As if the antennas on Mars weren't just transmitting images, but keeping part of a cosmic secret. Beyond Earth, 3I Atlas continues its journey, crossing Mars's orbit, drifting deeper into the sun's light. No one knows how it's changing in that distance, whether it's merely a melting shard of ice or something else, something waiting to be seen, when the conditions are perfect enough to reveal its true form. As always in the history of science, when silence lingers long enough, it stops being the absence of data and becomes a mirror for human imagination. Somewhere in the darkness between two planets, where signals fade and vanish, there may be nothing but numbers and radio waves. Or perhaps, there is something looking back, quietly, patiently, waiting for us to be brave enough to look straight at it. In the universe, some trajectories are defined not just by physics, but by intention. When 3I Atlas skimmed the edge of Mars's orbit, it seemed to carry a silent question. Could an anonymous block of ice and rock born in the dark between stars somehow know how to adjust its own course? When the data went silent, astrophysicist Avi Loeb, who once led Harvard's team studying Oumuamua, spoke up. He didn't make a claim, only posed a hypothesis, but one bold enough to make the scientific community hold its breath. What if 3I Atlas wasn't just a wandering object, but a complex system? What if it had released precursors, small probes quietly sent toward the red planet? The comet's trajectory made that scenario almost possible. Traveling at 60 kilometers per second, even a tiny change in velocity, 10, maybe just 5 kilometers per second, would be enough to break away from its main orbit and dive toward Mars. In the language of celestial mechanics, it's a simple maneuver. In the language of intelligent life, it's an act of intent. Loeb's orbital calculations showed that at its closest approach, Atlas would pass within 29 million kilometers of Mars. But the point where their orbits nearly crossed What astronomers call the minimum orbit intersection distance was only 2.7 million kilometers. In the vastness of space, that's practically a touch. If a fragment just a few hundred meters wide separated and was pushed with enough force, it could cross that distance in a matter of days. Some called it an outrageous idea, too daring, too speculative. But Loeb has never been one to chase myths. Years ago, he was criticized for suggesting Oumuamua might be the remnant of a light sail, a piece of interstellar technology built by someone or something. Yet later observations from the Spitzer Space Telescope and Pan-STARRS forced the scientific world to admit Oumuamua's anomalies couldn't be explained entirely by nature. Now, 3i Atlas seems to be replaying the same puzzle, larger, clearer, and far stranger. If 3i Atlas truly launched precursors, that could explain the moving light points seen in Perseverance's images. Some might be debris, but others appear to move independently, diverging from a comet's expected path. Those faint trails, drifting beside Atlas but not in sync, look like a school of fish peeling away from the current, gliding toward another direction in the ocean of night. But if small objects are really headed for Mars, why hasn't anyone seen them? Why hasn't HiRISE, the most powerful camera ever sent into orbit, capable of resolving details as small as 30 centimeters on the Martian surface, captured anything at all? The answer lies in the limits of technology itself. HiRISE was built to study the ground, not to catch fleeting objects moving through the sky. A 100-meter object hundreds of thousands of kilometers away would appear as a faint blur, lost in the noise of background stars. And if it moved fast, off by just a few degrees from the designated scan zone, the lens would never catch it. In the darkness of space, those tiny travelers might have passed by unseen, as invisible as the comet's own breath. Data from the James Webb Space Telescope shows that 3i Atlas is venting gas at about 440 meters per second, the natural escape velocity of heated molecules on its icy surface. But if part of its mass isn't dispersing randomly, and instead being directed, then something else is happening. A controlled thrust, an internal mechanism not just resisting heat, but using it. Loeb calls this the precursor probe theory. He imagines an ancient civilization that once sent out countless autonomous probes, drifting between stars for millions of years, dormant until they awaken under the light of a new sun. If that's true, then 3i Atlas isn't a traveler. It's a messenger, carrying tiny seeds of technology released to explore potentially habitable worlds. That idea brushes the edge of scientific faith. Because if something massive enough to exert gravity like Atlas also contains technology sophisticated enough to launch probes, then it's not a comet. It's a system, a mechanical organism adrift in space. A self-sustaining structure, like a cell floating in the cosmic ocean, holding within it the memory of a place humanity has never known. But as beautiful as that theory sounds, it still needs data, and the data for now remains silent. No images from HiRISE. No reports from Mars Express, no transmissions from NASA, only strings of quiet code stored on servers waiting to be decoded. In that silence, human imagination does what it always does, lights the darkness with questions. If probes were launched, where are they now? Maybe they entered Mars's atmosphere, swallowed by dust storms, never to be found. Or perhaps they landed softly in a barren plain, somewhere Perseverance's cameras never looked. Between speculation and silence, one thing is certain, 3i Atlas is nearing the sun, where light grows too blinding for any lens to follow. Within weeks, it will vanish into the solar glare, hidden behind the star's enormous fire. And when it emerges again, no one knows what it will look like. If it's just a comet, it will flare, vaporize, and fade away like every icy traveler before it. But if it's something else, a system with purpose, then when it returns from the light, its orbit might have changed. And that would be the first sign that it knows how to steer itself. Loeb's theory, controversial as it is, opens a haunting possibility. If 3i Atlas truly carries probes, then humanity might not be the first to observe the cosmos, but the last to realize we are being observed. In the silence of space, all forms of life, organic or artificial, share a single instinct. They send out signals, then wait to see who will answer. 3i Atlas may be nothing more than ancient ice and stone, or it may be the greatest question the universe has ever asked of us. A question with no words, only a faint blue light flickering over Mars, reminding us that sometimes the observer isn't always human. in the darkness between the stars, where the temperature sinks below anything we can truly imagine as cold. 3I Atlas drifts through space with a shimmering tail stretching millions of kilometers behind it, a silvery vapor trail that catches sunlight like a blade of light cutting through the void. By every classical understanding, a comet's tail is nothing more than water vapor, carbon monoxide, and fine dust evaporating from an icy core. But when NASA and ESA's spectroscopic telescopes began breaking down the light from that tail, a new mystery emerged, a spectral signature of metals that nature shouldn't be able to produce. Within the glowing mist of 3I Atlas, scientists detected clear, unmistakable traces of nickel, spread throughout its entire tail. Yet what silenced the room of physicists wasn't the presence of nickel, but the complete absence of iron, its inseparable companion in every cosmic body ever studied. In comets, asteroids, even dying stars, nickel and iron always appear together. They're born side by side in supernova explosions, bound by a nearly constant ratio, twin elements forged from the same stellar furnace. So why in 3I Atlas was only one twin left behind? Spectra from the Very Large Telescope in Chile showed nickel emissions 10 times stronger than those of any comet previously observed. But it wasn't in a normal metallic state. It appeared as vapor, atoms freely drifting as if they'd been heated to thousands of degrees, with no visible source of energy to account for it. On the frozen surface of an interstellar wanderer, where the temperature hovers just a few dozen Kelvin, the only thing that could vaporize metal is artificial energy. Researchers tried to explain it away. Maybe, they suggested, 3I Atlas once passed near the remnants of an ancient supernova, its chemistry altered by a shockwave. Or perhaps, over billions of years drifting through the galaxy, rare atomic reactions caused iron to condense into heavier compounds while nickel stayed free near the surface. But when the models ran on computers, none of the scenarios fit the data. Nickel shouldn't exist in this state, certainly not in this quantity, and absolutely not without iron. During a research meeting, a physicist in Zurich muttered half-jokingly, "If this isn't a calibration error, someone's running a foundry in space." The comment was omitted from the official report, but the idea lingered, that somewhere within 3I Atlas, a refining process might actually be taking place. On Earth, nickel is prized for its role in high-performance alloys, materials that withstand extreme heat and pressure in jet turbines, reactors, and spacecraft. It's the key ingredient in metals that remain solid and untarnished at thousands of degrees. And now, in the cold vacuum of space, nickel gleams once more, as if born from an industrial process rather than a natural one. If Atlas truly is making alloys, the question isn't why, but how. To turn solid metal into vapor requires temperatures above 2,700 degrees Celsius. No natural mechanism could sustain that kind of energy inside a comet without destroying it entirely. Unless, of course, the energy didn't come from chemistry at all, but from something more deliberate, perhaps a controlled reaction or an electromagnetic process humanity has yet to witness. Infrared spectrometers aboard the James Webb Space Telescope added another clue: faint but consistent electromagnetic pulses, repeating every 26 minutes, originating from the comet's core. A rhythmic vibration in deep interstellar space where nothing should vibrate. Scientists first suspected it was the resonance of cosmic rays crossing the tail, but statistical models ruled that out. The signals, it seemed, were internal. If someone, somewhere, had once launched self-replicating, self-repairing machines into space, they would need both energy and raw materials to maintain themselves. And to survive for billions of years, they would have to master metallurgy, the art of refining metal, an art reserved for civilizations that have long outgrown their planets. In the scientific community, no one dares claim such a thing outright. Yet deep down, even the most rational minds feel the same quiet thought. 3I Atlas might not just be a drifting body of ice and dust. It could be a factory, a silent workshop operating in the dark between the stars, for purposes we can't yet comprehend. In his report to the Harvard-Smithsonian Center for Astrophysics, Avi Loeb added a single note at the bottom: "If this is a product of nature, then nature has just proven it can build machines." That remark, philosophical as it was, carried a deeper implication. In the universe, there's no sharp boundary between what is natural and what is artificial. Stars give birth to planets, planets to life. Life learns to forge metal and harness energy. And maybe in time, sends that creation back into the cosmos, shaped into things like 3I Atlas. Perhaps humanity is merely witnessing the next phase of cosmic evolution, the point where intelligence and nature merge, becoming one and the same, no longer needing a body or a name. 3I Atlas might be nothing but ice and dust, or it might be a witness, a relic of some ancient lineage where unseen hands from eons past still work in the dark, forging metal out of nothingness. A quiet reminder that even in the stillness of space, the machinery of creation never truly stops. As telescopes continue to turn toward it, humanity begins to realize that the most unsettling idea isn't that life might exist elsewhere, but that it never truly disappeared. It simply kept working, farther away, quieter now, and with a precision too perfect for us to notice. Amid the endless expanse of space, where sunlight fades into a distant breath, 3I Atlas drifts onward. Its tail long, slender, and gleaming like a silver stroke against the black canvas of the sky. But when the Hubble Space Telescope captured its latest image, astronomers saw something impossible. Atlas's tail wasn't streaming away from the sun, but curving toward it, pointing back at the blazing heart of our solar system. According to every known law of physics, a comet's tail is always pushed away from the sun by the solar wind, that river of charged protons and electrons blowing outward from the star's fiery corona. It's a rule with no exceptions, proven by thousands of observations across centuries. Yet 3I Atlas refused to obey. In Hubble's photographs, its tail didn't stretch away but seemed to fold, twist, even whip back toward the sun, as if another invisible wind were blowing from within the comet itself. Physicists call this strange behavior an anti-tail. Sometimes comets in our solar system can appear to have one, but it's usually just an illusion, a trick of perspective when Earth's viewing angle lines up perfectly with the comet's orbital plane. But for Atlas, data from Hubble, TESS, and the La Palma Observatory all confirmed the same thing. The tail's direction was truly inverted, off by nearly 180 degrees from what theory predicts. This wasn't an illusion or a quirk of light. It was real. For any object to defy the solar wind, it would need an internal force, a mechanism powerful enough to eject matter at incredible speeds, overcoming the radiation pressure of the sun. In the vacuum of space, that kind of thrust would have to be hundreds of times stronger than natural ice sublimation, equivalent to the power of a jet engine. But no comet has an engine, at least not one we know of. Then came the spectroscopic readings, deepening the mystery. The material streaming from Atlas contained none of the usual volatile compounds, no water vapor, carbon monoxide, or ammonia. Instead, it was rich in nickel and heavy metallic ions, glowing at temperatures above 2000 Kelvin. Scientists at the Paris Institute of Astrophysics called it a metal wind, a dense, scorching plume erupting from the comet's core, aimed straight toward the sun. If it were a natural reaction, its activity should follow the comet's thermal cycle, intensifying as it neared the sun, fading as it drifted away. But the James Webb Space Telescope, JST, showed something different. Atlas's outgassing pulsed on its own rhythm, independent of distance. Every 19 hours, its emissions spiked sharply, then subsided, as if the comet were rotating on an axis, venting gas in periodic bursts, like a self-correcting engine adjusting its course. Nothing in the history of astronomy has behaved this way. Ordinary comets are fragile mixtures of dust, ice, and rock that simply vaporize under solar heat. Atlas, however, seemed to operate, managing its own mass loss, even maintaining stability. When NASA's Jet Propulsion Laboratory simulated its motion, they found that if Atlas truly expelled material against the solar wind, the recoil could subtly alter its trajectory, just a few thousandths of a degree each day. But over weeks, enough to shift it off its predicted path entirely. For an object to adjust its own orbit defies nature, unless it contains some unknown internal energy source. Perhaps a chemical reaction deep within, or a magnetic imbalance between hemispheres acting like a weak thruster. But such explanations would require a stable electromagnetic field inside the comet, something never before seen in any known celestial body. A research team at Cornell proposed another idea, a natural plasma engine. If molten metals inside Atlas became ionized, they could generate electric flows powerful enough to eject dust and gas outward, creating a faint but consistent reactive force. Yet to sustain that activity for weeks, Atlas would need a continuous source of energy. Not sunlight, not collisions, but something from within. That led to an even more unsettling possibility. The ejection might not be random at all, but intentional, an organized process, maintaining orientation, speed, or balance. If that were true, Atlas might not just be an ancient lump of ice and rock, but a functioning system. Astronomers, cautious by nature, avoided using the word engine. Still, it began appearing more frequently in internal reports, not as a declaration, but as a hypothesis. A jet engine doesn't have to be mechanical. Nature itself can create jet-like vents, like geysers or cryovolcanoes, driven by pressure. Yet the stable periodicity of Atlas, the directional precision of its tail, and the consistency of its emissions far exceeded what simple pressure could explain. In Hubble's final image before Atlas slipped behind the sun, its tail split into two distinct streams, one pointing outward, one curling inward. Two opposing flows within the same body, like a system seeking balance or something navigating through forces we don't yet understand. When the last data packet arrived, a researcher at NASA's Goddard Space Flight Center wrote in a private note, "If this is a comet, it's behaving like a ship." The line was never published, only preserved in an internal email chain, but it captured what the entire scientific community felt. The quiet awe of facing something that didn't fit within known science, yet was too precise, too measured to ignore. 3I Atlas continues its flight, cutting through sunlight, leaving behind a reversed, rebellious trail, a silver scar defying the laws written by the cosmos itself. And within every photon it reflects, humanity glimpses a paradox unfolding. Silent, steady, as if the universe were whispering its oldest truth, that even within the strictest order of its laws, there is still room for exceptions. And sometimes it is within those exceptions that life leaves its mark. Amid the eternal black sea of space, where light itself lingers only as the memory of long-dead stars, 3I Atlas drifts silently, leaving behind a chemical trail that has stunned the entire astronomical community. In the spectrum sent back by the James Webb Telescope, something emerged, faint yet undeniable, like the whisper of an ancient secret. Cyanogen. A pale blue compound, simple yet deadly, first discovered in the classic comets of our solar system. But this time, cyanogen stood alone. No methane, no carbon monoxide, no dicarbon, none of the usual molecules that define a comet's chemical fingerprint. Just cyanogen, hovering in the spectral light, isolated against a backdrop of nothingness. The absence of carbon, an element carried by every comet ever known, was a paradox. It was like hearing a symphony that plays only the violins. The rest of the orchestra vanished into silence. On Earth, cyanogen is the emblem of life reversed. Once used in toxicity experiments, it's a molecule capable of blocking oxygen exchange at the cellular level. Just a few parts per million in the air can end life in moments. And now, that same compound had appeared in an interstellar object, one that should have held nothing more than frozen water, ammonia, and the harmless chemical relics of the early cosmos. At NASA's Goddard Space Flight Center, astrochemists tried to reconstruct the sequence of reactions that could create cyanogen in deep space. They simulated ultraviolet radiation from the sun, the extreme cold of vacuum, collisions between dust and ions. Every equation ended in failure. Cyanogen couldn't exist alone without breaking apart, unless it was being constantly regenerated from a stable source. Some ongoing chemical process, repeating itself endlessly, maintaining its concentration within the thin halo around Atlas. If 3I Atlas were a natural comet, that would be impossible. But if it were a system, a structure capable of self-regulation, the mystery deepened. Cyanogen might be a byproduct of some other reaction, one humanity has never seen outside a laboratory. A few researchers speculated it could result from electrochemical processes involving metal in a vacuum, as if energy were being converted inside Atlas, and cyanogen was merely the exhaust, smoke from an invisible machine. In a brief interview, Professor Avi Loeb spoke slowly, as though feeling for meaning within the chaos. If 3I Atlas isn't deliberately trying to mislead us, it's doing an excellent job of it. His words were more than a scientific remark. They were a metaphor. The deeper scientists analyzed the data, the less sense it made. Atlas seemed built from carefully chosen components, similar enough to a comet to avoid suspicion, yet different enough to defy every natural model. Infrared readings revealed something stranger still. While cyanogen glowed strongly at 388 nanometers, there was no trace of hydrogen cyanide, the precursor compound required to form it. It was as if someone had erased every trace of the reaction, leaving only the final result. That led some researchers to consider the possibility of chemical masking, a deliberate arrangement of elements designed to confuse observational instruments. A synthetic curtain woven from familiar but unnatural signals, leading every analysis into a dead end. Behind closed doors, during joint NASA-ESA meetings, the phrase chemical masking began to surface. A few cautious experts suggested cosmic radiation might have distorted the data, but the consistent, stable signal across multiple observations ruled that out. Atlas didn't hold its strange composition for hours. It maintained it for days, even weeks, as if an invisible factory inside it were quietly operating, producing cyanogen in steady cycles, then venting it into space. If that's true, then 3I Atlas isn't a comet at all. It's a process, a chemical machine functioning in the void. And the real question is no longer who built it, but what is it built to do? Perhaps it's a probe designed to observe civilizations capable of analyzing light, like us. A trap of curiosity, an experiment in perception. Because cyanogen in the spectrum is an invitation. It draws attention, prompting scientists to aim their instruments toward it, unwittingly sending a message back. Someone is watching. Or maybe in some yet unknown way, it's entirely natural. A reaction between nickel, nitrogen, and cosmic radiation that forms cyanogen without free carbon. If so, 3I Atlas is a living fossil of pre-stellar chemistry, a relic from before the birth of carbon itself, before life, as we understand it, could even exist. Yet the absence of carbon, the foundation of biology, makes 3I Atlas a paradox incarnate. It's lifeless, yet exhibits complexity only life tends to create. Its chemistry behaving like intent, an inanimate system that provokes even the brightest minds to doubt their own understanding of the universe. Loeb once called Atlas an object designed to confuse. But maybe the confusion doesn't lie within Atlas. It lies within us, the species so sure we comprehend the cosmos, until the cosmos decides to rewrite its own rules. And in the dim vapor of cyanogen dispersing into the dark, 3I Atlas continues to drift. Each second, it releases tons of material, dissolving into space as a rhythmic chemical signal. Wordless, purposeless, persistent. It leaves behind only a quiet suspicion that somewhere in the vastness, there are things not made to be understood, but to test whether humanity dares to question its own understanding. In that silence, cyanogen, a colorless, odorless, lifeless gas, becomes the emblem of a grand paradox, that sometimes the most terrifying thing in the universe isn't what kills life, but what forces us to admit we never truly understood it in the first place. In the early days of October 2025, as the Martian sky faded into a pale pink haze of dust season, Perseverance, that small, steadfast rover on a silent, barren world, kept transmitting its steady rhythm of images back to Earth, like the distant heartbeat of humanity itself. Among those countless frames, one image made scientists pause and replay it over and over again. In the upper corner, among the flickering noise of reflected sunlight, a small, bright object streaked swiftly from east to west. It wasn't a star, nor a satellite, nor could it be debris. Its trajectory didn't match anything known. And then, the calculations began. If the interstellar object 3I Atlas, during its approach toward the solar system, had released smaller fragments, tiny probes propelled by some micro-recoil mechanism, then at an average speed of 60 kilometers per second, even a slight change in direction or velocity could have sent them toward Mars within weeks. Orbital simulations from Harvard's Institute for Theory and Computation outlined a plausible scenario. If the separation occurred in early September, the smaller objects would have reached Mars's orbit between October 4th and 10. That time frame aligned perfectly with the image captured by Perseverance. At NASA, there was no official statement. But in the independent research community, such a coincidence couldn't simply be dismissed. One of 3I Atlas's strangest traits has always been its shifting spectral signature, almost as if it were shedding pieces of itself. Several telescopes recorded faint glimmers detaching from the comet's core, each following a distinct curved path. Initially, they were thought to be chunks of sublimating ice, but under closer scrutiny, those lights didn't fade as ice should. They remained steady, reflecting light consistently, perhaps because they were solid, even metallic. If these small objects truly exist, each might be only a few meters across, maybe the size of a car. Too small to exert significant gravity, yet large enough to maintain independent orbits as they neared Mars. And if even one of them was moving deliberately toward the planet, then what Perseverance captured was no coincidence. Avi Loeb's once radical hypothesis suddenly began to sound unsettlingly reasonable. In a brief paper posted to Arxiv, Loeb suggested that if 3I Atlas were artificial, then sending autonomous probes, small self-directed explorers, would be a logical step. Any civilization capable of launching interstellar objects wouldn't waste us the opportunity to gather data while passing through a system that hosts life. If that's true, then the small bodies now orbiting Mars may have a clear purpose: observation. A leaked internal analysis from NASA's Jet Propulsion Laboratory included a short note beneath the Perseverance image. Object reflects light with irregular amplitude, 11-second oscillation period, possible rotation. A steady spin like that in Mars's thin atmosphere suggests a balanced shape, perhaps one designed for stability. These faint data points resonate strangely with NASA and ESA's ongoing silence. In every previous mission, unusual signals were shared quickly, like when Perseverance filmed dust devils or when InSight recorded Marsquakes. But this time, image streams from Mars were abruptly cut. Photos that once appeared almost in real time now arrive late, missing key time frames. If that silence isn't technical, there's only one explanation left. They're seeing something they can't yet explain. Independent researchers have attempted to reconstruct the object's trajectory from the Perseverance footage. Their models suggest that if it were within Mars's upper atmosphere, it would be moving too fast to appear sharp on camera. But if it were in a middle orbit, between Mars and its moon Deimos, the motion becomes reasonable. Neither too fast nor too slow, as if it were actively stabilized to maintain a steady gaze toward the surface below. In space, the smallest things are often overlooked: a grain of dust, a rock, a flicker mistaken for camera noise. Yet sometimes, those tiny glimmers are the truth, the first raindrops before the downpour of understanding. If these objects are truly probes, humanity might be witnessing something unprecedented. For the first time in history, it may not be us doing the observing, but someone else observing us. Perhaps a civilization so ancient it no longer sends travelers, only countless autonomous scouts, each no larger than a grain of sand, wandering through the stars in search of life. In a 2018 paper, Loeb and Manasvi Lingam wrote, "If a civilization is old enough, it wouldn't send people. It would send self-replicating eyes. Tiny, durable, intelligent grains of dust surviving for billions of years." From that perspective, 3I Atlas ceases to be a comet and becomes something else entirely, the mother of seeing grains. And if that hypothesis holds, then Atlas's passage through our solar system wasn't random. It could be a test, a return visit, part of a recurring cycle stretching across millions of years. A quiet reminder from the cosmos that something out there is still watching, still remembering that life once existed here, and now that life has learned to look back. Beneath Mars's dim red light, Perseverance keeps transmitting, steady and silent. No one knows what it might capture next, or whether NASA will ever reveal the missing frames. But one thing is certain: from the moment that small bright object appeared, the world was no longer the same. Because in that single image, there may lie the first greeting from beyond, not spoken in words, not shaped in form, but as a fleeting glimmer crossing an alien sky before vanishing into the void. And in that brief moment, humanity realized something profound. Perhaps we have never truly been alone in this universe. In the quiet expanse of space, there are moments when an object disappears, not because it disintegrates, but because the sun's own brilliance consumes its presence. That's the occultation zone, where every optical signal fades, and every artificial eye humanity has built goes blind. And in late October 2025, 3I Atlas entered that darkness. A moment astronomers have come to call, with a kind of clinical dread, the danger window, When an object passes behind the sun, it becomes invisible to all optical telescopes. Ground-based observatories, no matter how powerful, are helpless before that blazing curtain of fire. Only a few spacecraft, like the Parker Solar Probe in SOHO, can glimpse its spectral shadow. But even then, the data are faint, distorted, corrupted by solar radiation. For several weeks, 3I Atlas vanished completely from sight, a visitor from another star system that once drew the gaze of hundreds of telescopes, now hidden within the brightest light in the universe. For scientists, this is the most terrifying kind of silence, a data void. In that span of time, anything could happen. Atlas could disintegrate, change direction, or accelerate, and we would have no idea. Radar measurements, which depend on radio reflections, are useless when solar plasma drowns out the signal. The object, in a sense, drifts off the map of humanity. At the Minor Planet Center at Harvard, the data stream on 3I Atlas stopped on October 27th. Astronomers knew that when it re-emerged into view, it might not be where it was supposed to be. The same thing once happened with Oumuamua. It accelerated slightly and veered off its predicted path, as if nudged by an unseen hand. Now, 3I Atlas was entering the same stage, but with a closer orbit, a higher velocity, and a far longer silence. In a short essay for Scientific American, Avi Loeb rated Atlas a 4 on his informal artificiality scale, significantly higher than Oumuamua, which he once called the first possible sign of interstellar intelligence. The scale isn't official, but it reflects a quiet unease spreading through the scientific community. The sense that they might be facing something not entirely natural. Why does 3I Atlas feel so different? Not just its trajectory, but its behavior. Just before it vanished behind the sun, it emitted strange fluctuations of light, steady, rhythmic pulses like a heartbeat. Every 17 hours, its reflectivity rose slightly, then dipped, then rose again, a cycle that repeated for 2 straight weeks. For a comet, light variations usually come from rotation, but Atlas's cycle was too stable, unaffected by temperature, and seemingly immune to solar radiation. It behaved as if guided by an internal clock, a programmed mechanism. When it slipped behind the sun, that rhythm stopped. No more pulses, no more data, no trace of activity. It was as if the object had exhaled its final breath and vanished into the blaze. But no one could say whether that was an ending or a transformation. On Earth, observatories waited. They knew that by mid-November, 3I Atlas would emerge from the occultation zone and become visible again. But during those waiting weeks, a quiet fear crept into every meeting. What if Atlas didn't follow its predicted path? If it shifted course, there would be only 2 explanations. Either an unknown natural force, or something within it making that decision. Gravitational modeling from JPL showed that even a deflection of just 0.01 degrees would require a thrust of about 1 million newtons, the power of a small rocket launch. In the vacuum of space, such force can only come from outgassing or propulsion. But if the amount of expelled material didn't match the observed change, then one conclusion remained: the energy came from within. A few researchers began to refer to this period as the silence before intention. Because when an object disappears from sight yet might reappear somewhere unexpected, it stops being merely celestial. It starts behaving. Radio telescopes, unaffected by sunlight, were aimed toward the region where Atlas was traveling. But they picked up nothing. No radio waves, no gamma bursts, no radar echoes. Only perfect silence, so absolute that it made one wonder whether it was the absence of sound or the sound of absence itself. When something from beyond imagination slips behind the sun, humanity is forced to confront the limits of its vision. Light, the only tool we have to see the universe, can also become the wall that blinds us. The sun, the source of life, is also the veil of ignorance. Behind it, anything might happen, and no one would know. In that blazing shadow, 3I Atlas became a spectral traveler. Not just an object, but the embodiment of disappearance, the boundary between what we know and what we cannot. When asked about the possibility of Atlas returning on a different trajectory, Loeb offered only one sentence: if it changes course, it means it knows where it's going. Half science, half prophecy, but it lingered in the air like a warning. As instruments prepared for its reappearance, no one dared to predict what would come next. Because in those short weeks behind the sun, 3I Atlas hadn't just vanished from the sky. It had slipped beyond the framework of order itself. It had become a symbol of science's deepest unease, that the universe is not silent at all, only speaking in a language we have yet to understand. Behind the sun's blinding glow, where no gaze can reach, 3I Atlas drifts, perhaps still moving, perhaps waiting, perhaps already changing course. And when it emerges again, even a fraction off its expected path, humanity will have to face a sobering truth. In the endless game between knowledge and ignorance, sometimes it is the light, not the darkness, that keeps us from seeing what's real. Since the dawn of the space age, NASA has defined itself by one core principle: transparency. Every discovery, every image, every signal from distant worlds has been shared openly, as if it were a sacred ritual of knowledge passed to all of humanity. Raw data from probes, Voyager, Perseverance, and countless others, has always been uploaded to public servers. Anyone, from leading scientists to first-year students, could access, observe, and help interpret the universe. But in the autumn of 2025, that principle suddenly changed. 3I Atlas, the third known interstellar object ever detected, crossed Mars's orbit with an unusual spectrum, strange metallic signatures, and a cometary tail pointing toward the sun. Then, without warning, all data stopped. Not slowed, not delayed, stopped entirely. Telescopes that should have been constantly active, Hubble, James Webb, TESS, even Parker Solar Probe, Psyche, and JUICE, all went silent at once. No new images, no spectral reports, no updated orbital data. The silence spread like a vacuum of knowledge, swallowing the entire research community. On professional forums, astronomers began to wonder, was this a technical malfunction or a deliberate decision? A leaked memo from NASA's Goddard Space Flight Center stated that data regarding 3I Atlas was under interagency review. In bureaucratic science speak, that phrase means the data is no longer public. It's locked within international institutions. The prolonged quiet was so strange that people began whispering what no one dared say aloud, that information might be under control. No one confirmed it, yet every sign pointed in the same direction. Hubble's public database showed no updates after October 20th. James Webb, which normally transmitted images steadily through NASA's Deep Space Network, disconnected 3 times in November with no official explanation. TESS, designed to track stars for exoplanets, abruptly shifted its focus to a different section of the sky, right as Atlas neared the sun. When pieced together, these movements formed an uneasy picture, a silent consensus stretching from Washington to Paris to Tokyo. In the history of space science, there have only been 2 similar silences. The first came with the WOW signal in 1977. The second, when Oumuamua's orbital data was quietly altered in 2018 with no reason given. Both ended the same way, with fading media coverage and official silence. Now history seemed to repeat itself, only this time on a scale far larger, more intricate and absolute. Beyond institutional walls, amateur astronomers, free from political or security constraints, continued to watch. From the Atacama Desert, from observatories in Australia, Japan, and South Africa came scattered reports. Someone saw 3I Atlas flash unusually bright before dawn on November 5. Others claimed it pulsed with a rhythmic change in brightness, almost like a signal. But gradually, those voices vanished. Their accounts went inactive, forums disappeared, posts were taken down without explanation. Only a few fragments of data remained online, blurry, incomplete, like faint relics of a story being erased. Those who study the history of science know, when a phenomenon is hidden, it's usually because it doesn't fit comfortably within our worldview. And 3I Atlas, with all its orbital oddities, chemical anomalies, and the silence surrounding it, seemed to have touched that very boundary, the line where science and fear converge. A researcher at the European Space Agency, speaking under anonymity, said quietly, "It's not that we don't know, it's that we don't yet know how to say it." The words were simple, but chilling, a rare truth. Sometimes knowledge isn't concealed by power, but by uncertainty over what it implies. Because if 3I Atlas truly didn't behave like a comet, if its signals were intentional, that would mean humanity is no longer the only observer in this universe. And perhaps silence is the only response a young civilization can make when faced with something beyond its control. Back on Earth, telescopes still point toward the empty space where Atlas once passed, but there's nothing there now. No flicker of light, no trace of dust, no echo of a radar return, The object has vanished or become something beyond human perception. Silence, once merely the pause between sounds, has now become the essence of the universe we gaze into. Maybe 3i Atlas will never return. Or maybe it's still there, hidden behind the sun, waiting for a moment when humanity is ready to understand. Until then, one question lingers, faint but unyielding, like a dying light in the dark. What could make every eye on Earth turn away at once? And if something had that kind of power, perhaps it never truly left us. In Greek mythology, the Trojan horse didn't arrive with weapons. It arrived with trust. It was a symbol of victory, yet also a doorway to ruin. Out in the darkness of space, among the cold pinpoints of starlight, 3i Atlas carries the same aura. An object that seems natural, drifting without purpose, but perhaps hiding something far beyond human understanding. When 3i Atlas slipped behind the sun, all signals stopped. But just before it vanished into the blinding glare, the last readings from the James Webb Space Telescope revealed something strange. Its thermal emissions dropped sharply, almost to nothing, while its reflectivity increased. A body growing colder but brighter, as if it were shedding its outer layer, a behavior never before seen in comet physics. Some researchers began calling it the shedding event, an inexplicable transformation. But to others, it hinted at something deeper, a deliberate change. That's where the Trojan horse hypothesis began. If 3i Atlas is a comet, then its actions make no sense. But if it's a constructed object, built for a purpose, the contradictions become eerily logical. Orbital models posted on Arxiv show that 3i Atlas doesn't fully obey Kepler's laws. Subtle, measurable deviations suggest its path is being adjusted. When scientists at ESA combined data from September to October, they found Atlas had slowed by about 0.1%. A minuscule number, but impossible by natural means. A comet can sublimate, fragment, or spin apart, but it cannot break unless something inside is working. Avi Loeb, who once faced a storm of skepticism for questioning the natural origin of Oumuamua, surfaced again. In a brief interview, he said, if someone wanted to send a machine to observe a civilization without being detected, they wouldn't send a spacecraft, they'd send a comet. A simple line, but enough to ignite speculation throughout the scientific community. Because if a civilization can steer an interstellar object, it's wise enough to disguise it in nature's own language. Spectral data from 3i Atlas shows unusually high nickel content, no iron, and what appears to be an energy-reflective metallic compound, almost like a mirror coating. Some physicists have called it an alloy that shouldn't exist in nature. If true, Atlas could be a metal shell wrapped around an empty core, a comet skin fabricated to conceal something within. And if inside there's a structure, or worse, a functioning system, then Atlas is no longer a simple physical object. It's an entity with a goal. The real question is no longer, what is it, but why is it here? Throughout evolution, every form of life, from single cells to self-aware intelligence, has sent out signals, emissaries, messengers. Atlas may be one of countless such messengers, drifting for billions of light years, passing thousands of star systems, gathering and transmitting information. A reconnaissance tool, not unlike our own Voyagers, except for one crucial difference. We know we're observing, but Atlas doesn't let us know it's observing back. If that hypothesis is true, its implications go far beyond science. An artificial interstellar object wouldn't just be a discovery, it would be a mirror. It would force humanity to confront its greatest question. Are we truly at the center of cosmic knowledge, or just latecomers following the traces of those who came first? In closed-door meetings between NASA, ESA, and the Harvard-Smithsonian Center for Astrophysics, no one confirmed, no one denied. They spoke only of communication risk, of global destabilization. Because if something from deep space can steer, decelerate, and be manufactured, that means an intelligence exists, and it has already been here. Around the world, science journals remain silent. No headlines, no warnings. But in internal technical notes, a new term is surfacing: Trojan object. A phrase at once scientific and mythical, a body that carries something within, cloaked in a natural shell, waiting for its moment to activate. Throughout history, humans have assumed danger comes from outside, from distant stars, from things falling through the atmosphere. But what if the threat doesn't fall, but drifts quietly past, wrapped in the guise of a harmless comet? Who would even notice? Right now, 3i Atlas is behind the sun. No one can see it. No one knows what it's doing. It might still be gliding onward like millions of other objects, or it might have stopped, changed course, or begun operating from within. No one knows, and perhaps no one dares to. In the sun's blinding brilliance, everything is hidden. Even with humanity's greatest telescopes, we cannot pierce that glare. And maybe, within the very light we think of as truth, lies something we cannot see. If 3i Atlas truly is the Trojan horse of the cosmos, then the door has been open for a long time. Not with weapons, but with curiosity, the instinct that keeps humanity looking up at the sky. And like the citizens of Troy long ago, we've pulled the horse into the center of our city of knowledge, called it a comet, and believed it harmless. But perhaps the universe doesn't always send us enemies. Sometimes it sends a question so large it could forever change how we see ourselves. And until 3i Atlas emerges from behind the sun, silent and unannounced, that question hangs in space. Are we looking at an ancient fragment of ice and rock, or staring into the face of an intelligence that arrived long before we did?